You have a population of 50 rabbits with a heterozygosity of 0.6. Find the expected heterozygosity. So in this problem, we are going to be using the equation I just put in my previous slide, which would give this. So again, just for recap, expected heterozygosity, current heterozygosity, population size. So just plug in what we know. We know we're solving for the expected. So we have a heterozygosity of 0.6 of 1 minus, these ones don't change, 2 times 50. And from here we just kind of just simplify it out. So again, these ones are kind of our constants. This phi will, they won't change, but here 2 times 50 is 100. So 0.6 parenthesis 1 minus 1/100th. And then just kind of go down here for more room. 0.6 of 1, and then 1/100th, that's kind of messy looking, so 1/100th can also be written out as this, because again, if you remember, tens, hundredths place, 1/100th, 1/100th, tens, hundredths, right? And that gives you with this, please excuse my dear Aunt Sally, parentheses first, 0.99. This is kind of messy to do. You can maybe approximate. It would be around 0.600, but just to get the correct answer, I would just do, if you didn't have a calculator, log division it out. 0, right? So every times 0 is 0. I'm not even going to look at the decimal places. So we're on this now, our second digit, just add a 0, 54. 9 times 6 is 54. 4 at the 5 up here, 9 times 6, 54 again. 54 plus 5 is 59. 9 here, at the 5 here. 6 times 0 is 0, and then the 5 remaining from the last one. And the 5 is remaining because you can't go over 10. The highest digit you could have is 9. Anything over 10 is carried on. And then for the last one, it just looks like it's 0 again, so I don't really care. Just for fun, just add 2 zeros, and it doesn't really matter. So add it up, 0, 4, 9, 5. Again, there are 4 digits total to the right of the decimal place. 1, 2, 3, 4. Your decimal place is always here to start with, but we have 4 to the right of the decimal place, so we go 1, 2, 3, 4. So the answer for our problem would be 0.5940. That would be our expected heterozygosity after genetic drift. So it would drop slightly. Again, keep in mind this is a very bare equation. It doesn't take into consideration a lot of factors, as I said on the previous slide.